Hello, this is a presentation from Kuzu Console to the Alaya network. In this presentation, we'll learn how to build a decentralized application on the Alaya network using the Python SDK to create a smart contract which will be used to process a transaction on the network. We will learn how to create a smart contract and connect the Alaya development network using the Python SDK. We will learn how to create a wallet and an account address using the Samurai Chrome extension. And then we will also learn how to process a transaction which will be used to send ATP token from one account address to another. So before we get started, let's take a look at the Alaya client SDK for Python, the GitHub repository. So this is what we have here. Go ahead and clone this GitHub repository or download the repo into your local machine. After doing that, we're going to start our whole development processes, and this is what is required for the installation. We need Python installed. We also need our client SDK Python. We can install it directly here. We can also clone the repo using this git command right here, and then we can see some other code snippets that we can use to do some basic things on the Alaya network. Of course, we can see our development chain ID, which we are going to later use in this tutorial. So right here, I have my Visual Studio Code open, and I'm going to go ahead and create a new file, and then select language type, which is going to be Python. Go ahead and do that. So I have successfully created my Python program on the Alaya network, and I have named it Alaya transaction test. So we can see it. This is the client SDK Python that I installed from the GitHub repository, cloned rather. We can see the test folder, and then this is the new Python file that I created. So the first thing we're going to start by doing, we need to import the client SDK package into our program right here before we can make use of it. So let's go ahead and get started. From client SDK Python, we're going to import the web, no, not the web packet, the web tree. And then we also need the HTTP provider. And then secondly, we are going to import .eth. Import, we are going to import Python because we are going to make use of it. And then lastly, from client SDK Python.utils transaction, because we are going to make a transaction, we are going to need this. So we are going to import get block gas limit. Go ahead and do that. So after importing this namespace, these packages rather, we are going to get started with our next development phases. So the next thing, we need to connect our application to the Alaya development network. So I'm going to create a variable here, and then making use of the web tree that we imported, I'm going to pass in the HTTP provider. This HTTP provider is going to contain the URI and the chain ID that will be used, and then we have our chain ID. Okay, so right here, we are going to go back to the browser to get the HTTP provider URL and also the chain ID. Okay, so back on the browser, we are on the Alaya website documentation for the development. So we can see here, we have the Alaya main network will be officially launched on October, which is last year. And then this is the chain ID that will be used, 201018. And then the other is a development network, 201030. And we are running our tutorial video here with our source code. We'll be running it on the development network. So of course, we are going to use this chain ID on the development network. And then if you scroll down a bit, we are going to get our URI, which is this URI here, the open RPC URL. This is what we are going to pass in into our HA provider function or method for us to be able to connect to the Alaya development network successfully. So go ahead and copy this URL and also the chain ID on the development network. Okay, so let's go ahead and pass in the chain ID that we got. So having done that, let's go ahead and also paste in the URL. So now that we have done this, we are going to make use of the Platon. We're going to create another variable and then connect it to the Platon, which is what we imported up here. And then we're going to pass in W3. Perfect. So to test if our connection is valid and if we are truly connected to the development network, we can decide to use a method which is making use of the W3 dot is connected to check if or whether or not we are connected successfully. So go ahead and do this and then run the application. So let's go ahead and click on this green play icon here to run Python file in terminal. Go ahead and do that. Okay, so our terminal just popped up and we can see our result is true. Let's go ahead and try it one more time. So which is true again, which means we are connected successfully to the Alaya development network. We have the correct chain ID, we have the correct URL. So the next thing we're going to do, we are going to pass in or create another parameter, ABI, containing a sequence or an array of data types here, which will be used in our program later on. So we have this long array of items, a collection of items. We are also going to need a bytecode. So I'm going to create one. So I'm going to go ahead and paste in the bytecode. In case you're wondering where you can get the bytecode from, if you are using the Alaya Studio, that's the Travel Studio, using Solidity Smart Contracts, you can actually get your bytecode from there. So right here on the browser, you can see the IDE on the Alaya network, Alaya devdocs.en/en/IDE. So you can actually use that depending on the device you're using. If you're using a Mac OS, you have to install Linux or Windows with the necessary steps available for you to do that. Of course, we are not doing Solidity here. We are using the Python SDK for those who are interested in using the Python SDK to build on the Alaya network. So the next thing we're going to declare is from address, because we are dealing with transactions who we are going to send ATP tokens of funds from one account address to another account address. We're going to definitely have from address, which is the address that we are going to send funds from. So we are going to declare that also. And if you're wondering where one can get an account address, we can use a Samurai extension. I'm just quickly going to take us to the browser where that can be gotten from. So right here on the alaya.network/alaya devdocs documentation, we can see where we have our Alaya accounts drop down here under basics. So if you scroll down furthermore, we can see how we can create account addresses, what a private key is, what a public key is, what an address is. And we can also see several ways that we can create our account address. You can also see a mnemonic key. Of course, this is all on the development network, so no real transactions will actually be made per se. Everything is done for development purposes, for learning purposes. So we can actually either make use of the Platon mobile app. You can install the mobile app. We can see the link. I will drop the links to all of this below in this slide. And then we can also create a wallet using the Samurai extension, which is what we are going to use. You can use the Alaya key command line tool, and then the M tool, which is a tool on Windows and Ubuntu. It's very easy to use. You can refer to this link right here, and then we can make use of the Samurai wallet also. So the Samurai wallet is very similar to MetaMask if you have used one before. you can use it to create your account address on the development Alaya development network. So this is what we are going to use, and then to install it we have to make use of the Samurai Chrome extension. So we have to uh, download it, go to the extension site, you can see an image here, turn on the developer mode, and then click on load packages, and then import that package which was installed into this place for you to complete the installation of the Samurai extension or the Samurai wallet, which will be used on the browser as an extension. So right here, I have my Chrome browser open, an empty window. And then if I scroll down to where extensions are, you can see some of the extensions I have. And then we can also see the Samurai extension, which is what I have here. And of course, if you don't have an account, you'll see the necessary steps needed. Either you import an account if you already have one, or you create a new one, which you can use to generate your account address. And then it has several networks. You can be on the Platon main network, Platon dev network. You can be on the Alaya network. You can be on the Alaya dev network. You can be on the custom RPC. But for development purposes, for this tutorial sake or demo, we are going to make use of the Alaya dev network, and which is the current network I am in. So we can see the account's address here, which can be copied by just clicking on it. You can also click on this three dotted icon here, and then you can decide to expand view, check the account details, view on PlatScan, and see connected sites. And then we can also fund, of course, this account address it has already been funded. So to do that, if you have just recently created your account address and you do not have funds there, you can click or head over to buy, and then click on get test token. This will take you to the faucet.alaya.network, where you can paste in the account address, paste in the email address that you want to use, and then click on the click to verify. A verification code will be sent to the email address, and then you will use that verification code here and then click on apply. It takes about roughly, let's say, 10 seconds for your account address to get funded without any hassle. So back to the extension, I'm going to go ahead and copy this account address because I have already created it already. Then we can also view other details, like clicking on this to view account details, expand view, view on PlatScan. So for now, let's go ahead and click on view on PlatScan. We haven't done any transaction as of now yet, but we have previous transactions. We can see about 8 previous transactions. You can see the current balance, and then we can see some details about it. So we're going to head back into our code now that we have copied and we have seen how we can create an account address on the Alaya network. So back into our source code, from the from address, we are going to paste in the account address that we copied from the Samurai wallet. So the next thing we're going to have, we're going to pass in the gas that will be used. So we are going to make use of this get gas limit that we imported earlier on. So we are going to make use of that, and then pass in our W3, which we declared earlier in the program, and then subtract by 1. This is like a constant that we can use as for our gas when trying to run a transaction. Okay, so let me go ahead and minimize or close or kill the terminal completely. So the next thing we are going to pass in is the private key. We're going to declare a private key which will be used. So to get the private key, we are still going to go back to our browser and making use of the Samurai extension, the wallet there, we will get the private key for this particular account address that we got or that we have. So to do that, we're going to click on this and then head over to account details, and then we can see the account address here. We can view on PlatScan, and then we can export private key. So go ahead and click on the export private key and then enter the password that you used to create that you used when creating the Samurai wallet. So go ahead and do that. We can see our private key, and then take note that we can see a warning here: never disclose this key anyone with your private key can steal any assets held in your account. So try as much as possible to keep your private key very secret. Keep it in a safe and secure place, away from hackers or anyone who might have an illegal access to it, because your private key can be used to do almost anything. Lots can be, you can lose a lot of assets, almost virtually everything, your funds. So try as much as possible to keep that private. This is being publicly displayed in case you have never seen how a private key looks like, and of course this is for demo purposes, development sake, and tutorial. So no real transactions will be made here on the development network, but when you're on the main net, on the main network, and never ever disclose your private key. So I'm going to go ahead and copy this private key and then click on done. So back inside of our program, I'm going to go ahead and paste the private key that was used. So the next thing I'm going to pass in as a parameter is a chain ID. So I'm going to go ahead and do this. Okay, this should be an underscore chain ID. Of course, this is the ID that can be used, and you can also make a global declaration of your chain ID and pass it maybe somewhere outside here, and then reference the chain ID in here, or you can pass it directly as it is here. So I'm just going to go ahead and copy this. It doesn't matter how you do it, so long as you pass in your chain ID. So I'm going to redeclare it here. This is going to be used further down below. And then lastly, we are going to pass in what we have as our gas price. And then this is going to be about 1 billion, or 1 with 9 zeros. So the next thing, this is where the whole transaction phase will be. So I'm going to go ahead and comment transaction method. So to begin with this, we are going to declare a function, and then I'm going to name this transaction dictionary. Okay. Then we will pass in data, and then 2, that is the person we are sending to. For now, it's going to be none. We will not pass in any real send receiver. Then we are going to return pass in data. It is going to contain our data, and then let me just bring this down and then continue like this to maintain code readability. This should come down like this. So yes, we have from, and then we will pass from address. That is the address that we are sending from, and then we will also pass in the gas. Okay, gas, and then this will be the gas that we pass in at the top above there, and then we will also pass in chain ID. Chain ID will be the chain ID that we have above also, and then we'll also pass in the gas price. That will be the gas price that we have outside also, and then we have our nonce. Inputs, and that would be pattern dot get transaction. Okay, the transaction count method. Go ahead and use the get transaction count method, and then pass in from address, that is the sender. And then lastly, we have to who we are sending to, that is the receiver of this particular transaction. And then 2, we pass that to none, so we don't have any real receiver yet, but we are going to subsequently add that later on. So this is going to be 2. Okay, so having done this, we are done with this function. We are going to declare another function outside of this. Okay, so for the next function, we are going to call it send transaction. this is what is actually going to send the transaction on the Alaya network, and then we'll pass in our TXN. Okay, so then we can begin signed TXN representing signed transaction. We are going to make use of the pattern account, and then signed transaction, and then this method will pass in our TXN for transaction, and then our private key, then that will be passed in as our private key, and then we are also going to have the uh, net type. Okay, so the net type will be of type ETP. Okay, we have a typo here. So yes, so representing ATP, this should be a single goods. Okay, like this. So that is it for signed transaction. And then the next one will be REST. This will contain the pattern that send raw transaction. Okay, pattern that send raw transaction. So we're going to make use of this send raw transaction method and then pass in the signed transaction that we just worked on, and then we will also make use of it and then dot. Okay, so the raw transaction like that, and then we are also going to work on the text. This is also a method. Okay, so having done this, the next thing is our transaction receipt. So TXN, then we will pass in the receipt. So this is going to make use of the pattern that with transaction receipt. So all these things are built-in functions, and one depends on the other. So making use of the rest that we just declared here. So having done this, we can go ahead and tell our application to print out what we want. So we can tell it, okay, print out send txn and rest. So that should be rest, and then we should also print out our send txn receipt. Okay, and then that should have the transaction receipt. And then lastly, we would like the method to return our transaction receipt. So yes, we're almost done, remaining the last few steps. Okay, so the next step, we are also going to declare another method. I will just go ahead and quickly paste that in. So we have a function, we have WebAssembly deploy. Okay, this should be TXN transaction. Okay, yes, WebAssembly deploy by signature, passing in as, so which is like a key value pair that we passed in. And so inside of the method, we have our encode data, making use of the Platon.contract. We are passing in this ABI that we declared at the top, which is above right here. And then we have our bytecode, which is also going to be passed in inside of the contracts function, and then making use of the encode constructor data, also having the key value pairs. So at the end of the function, we have our send transaction, make use of transaction dictionary, and then passing in our encode data into it. And then lastly, we have this WASM deploy by signature method being called directly at the bottom here. So having done this, having written this code snippet, I believe this is what we need. This is all we need to be able to run transactions or make a transaction on the Alaya network. We don't need this package that was imported when we were trying to pass in the private key right here, I think. So yes, these are the three packages that we need to import, and then we have to make sure we are connected correctly on the dev network. We need to pass in the appropriate parameters ABI bytecode from address, gas, private key, chain ID, gas price. And then we have this function that is going to determine the type of transaction that we will be making, who we are sending to, the key details or key parameters that needs to be passed in. That is what this function is handling. And then we have a send transaction function, which is actually going to process that whole transaction process. And then we have wasm deployed by signature, passing in our encode dynamic keys of API and bytecode. All right, so having done this, we can go ahead and run our application to test it out. Okay, so having done all of this, we can proceed or go ahead by running the Python file in terminal. So we can do that by clicking on this icon right here. So we can see through here, which means we are connected successfully. Okay, I think I clicked that twice. Okay, so all the same, we had a successful transaction. I think I clicked the run Python file in terminal 2 times. So we can see our transaction receipt, the hash here. We can see our transaction receipt and the attributes. You can see the block hash, the block number, the contract address. We can see the cumulative gas used from, which address was used to send from. And then most importantly, let me go ahead and increase this. This status is 1, which means we had a successful contract sent and everything worked successfully. We can see the gas used and other details about this transaction. What we have 2, which is supposed to be the receiver, is none, because we have none as the receiver. We did not pass in the receiver address, or we did not pass in a receiver to it, so which is why it is none. We can go ahead and check on the browser to see it live on the flat scan. Okay, so back in the browser where we have this, okay, nope, the Alaya Blockchain Explorer. So I'm going to go ahead and refresh this. Okay, so we can see the transaction we just ran about right now. So yes, we can see its success. We can see the time. Remember, we ran it 2 times. It was around 4:52 p.m. and then this is for the second one, and then we can see the first one that we ran was around 4:52, still the same time, just split seconds separating it. That was second time and first time that it ran when I clicked to run the Python file in terminal twice. So we can see a successful contract deployment. Everything worked fine. So you can also go back. I'm going to open this in a new tab. We can go to the home on the blockchain explorer and then see other details. You can see validators, you can see blocks, you can see transactions, and so many other things on the network. So we can explore this. Is of course on the developer network. So you can go ahead and, if you want to try testing a transaction or sending transaction from one account address to another account address, you can go ahead and, since this is all on the development network, no real funds will actually be sent. You can always top up your Samurai, your account using the Samurai wallet, or using this rather, the faucet.alaya.network. You can always go ahead and fund your account. So you can just get any other account address and then use that as the receiver of the funds that we are trying to test or send to on this tutorial. So I'm going to go ahead and copy just the random account address and then head back to the code. Okay, so having copied that, I'm going to go ahead and replace this none with a receiver address. So by doing that, I'm going to go ahead and let's take a look at the price, how much we are sending, the gas price and everything. Okay, everything looks good and fine. So yes, we can go ahead and proceed with the contract. So click on run Python file in terminal. I'm going to go ahead and expand this. So yes, we can see details, and then this time around we have two, which is the receiver, and our transaction status is one, which means it was successful. Unlike here, the two here is none, which means we did not pass in any real receiver of it. So here we have an address which will be received or which will be sent to. And then if we head back to the browser, we will see that. Okay, so back on the browser, I'm going to go ahead and refresh and then scroll down a little so we can see contract creation, but then this time around what we have here type was sent, which means the transaction was sent. We can see a success, but we did not pass in any amount. Just for demo 6 we are not trying to pass in funds. So in case you want to add, you can go ahead and add that. But then we can see a successful transaction. We can see the details, transaction hash, the timestamp, the gas used, the gas limit, the gas price, and all of that. So yes, we have successfully come to the end of this tutorial. Just a brief recap, we have learned how to the first thing we learned was to how to clone the Alaya GitHub repository to our local system, and then we learned how to create a Python file and connected it to the Alaya network successfully. We also learned how we can create our making use of the Samurai wallet on the Chrome extension to create an account address on the Alaya development network. And then we learned how to process a contract which will send transaction from one account address to another account address.